that we're going to do everything from this base station. We will define like a plot area.
The robot that we're using in the project is a four-legged robot that's called a quadruped, or like a robot dog is what people might commonly call them. And they've been getting more and more capable in terms of walking over rough terrain, up hills, over bumpy rocks and tree branches and things like that. So it's become more possible to be able to use this kind of robot to walk around in a forest, and with our mapping technology to build 3D reconstructions of the area around the forest.
Thank you.
We're able to cover larger distances, to be able to map a couple of hectares, for example. And the sensors that we use are laser sensors, the same kind of sensor that's used in self-driving cars. So it measures distance out to each of the trees, and from that we can reconstruct basically the kind of cylinder shape of the trunks, and measure their diameters and measure their heights, and build up basically a database of the contents of the forest. With longitudinal measurements, so multiple measurements over different seasons, as trees grow, you can get a measure of the growth rate, and with the growth rate, you can detect where maybe a forest is struggling, or where there might be trees that are dying. You can also use this kind of 3D model to project or plan interventions. So if you were to knock down certain trees to protect the rest of the forest from, say, strong wind damage, or a forester actually planning which trees they want to knock down.
So do you keep all the point clouds?
But I think they should be all the points that we capture for that specific tree.
Yeah.
This walking robot is called Animal, and it's actually developed by a Swiss company called Anibotics, and their particular focus is on industrial inspection. So having the robot walk around industrial plants, even oil and gas plants. It's quite a domain shift from those kind of sectors. And through that, it's developed to be IP rated, which means it's waterproof. Really getting it out into the forest environment, where it has to deal with unexpected foliage, trip hazards, roots, all of the kind of things that, when you go hiking, is a challenge for you to make progress. So one side of it has been improving the robot's ability to walk, so that it's able to be more rugged and doesn't fall over. And the other side of it is planning and developing its autonomy stack. So it does things like scan through a plot that we're interested in without missing any patches. So it has to build its map as it's going, so as to be able to know where it's been and where it's not been. really the challenge is to change the mindset of the forestry community to adopt this technology. And there's still challenges because it's expensive technology going around facilities that are remote in many cases. But that's the challenge.
Pelan-pelan. Pelan-pelan, Pi.